Hello everyone, I am Sisan Regmi from Mahindra Ratna campus Tachal, and today I am going to give a short presentation about deadlock and its characterization, preservation, detection and avoidance. So what is deadlock? Or deadlock is a situation where two or more processes are blocked forever, each waiting for resources held by another process in the same group. As a result, none of the process can be processed and one of the resources are ever released. Common example is process A holds printer and waits for scanner. Process B holds scanner and waits for the printer. Let's take an example of one lane bridge. So when a bus enters from Kathmandu on the bridge and another truck try to enters on the bridge from Pokhara. So when both of the drivers don't want to reverse, then the deadlock occurs. Deadlock characterization. There are four necessary conditions to satisfy deadlock. Mutual exclusion. At least one resource must be held in non-shareable mode. Hold and wait. A process hold a resources while waiting to acquire another. No permission. A resources can only be released voluntarily by the process holding it. Circular wait. A closed chain of processes exist each waiting for a resources held by the next. Let's understand deadlock characterization with the help of an example. Suppose there is a one-lane bridge between Kathmandu and Pokhara. A bus enters from one side and a truck enters from other. Neither can move forward and neither wants to reverse. Both keep waiting for each other. This situation is called deadlock. The four conditions are satisfied. Mutual exclusion. Only one vehicle can use the bridge at the time. Hold and wait. Each vehicle occupies part of the bridge while waiting. No permission. You cannot force a driver to move. Circular wait. A bus waits for the truck and the truck waits for the bus. Deadlock prevention. Prevention works by ensuring at least one of the four necessary conditions can never hold. Mutual exclusion allows share access wherever the resources type permitted. Hold and wait require process to request all the resources at once before execution begins. No permission allow the OS to forcibly take back a resources if a request cannot be granted. Circular wait impose a strict ordering on the resources type and request them in that order. Let's understand deadlock preservation with an example. To prevent this problem, a traffic police officer allows only one side to enter the bridge at a time. Vehicle from other side must not wait until the bridge is completely empty. Result: no deadlock occurs. Deadlock avoidance. Instead of restricting how resources are requested, avoidance checks each request is in advance. The system only grants a request if the resulting state is still safe, meaning every process can still finish. This requires advanced knowledge of maximum resources each process may need. So there is also an algorithm for it known as Banker's algorithm, the best known avoidance algorithm. It stimulates resources allocation before committing to it, reject all any requests that could lead to an unsafe state. Let's understand deadlock avoidance with an example. Before allowing a vehicle onto the bridge, the traffic police checks whether there is enough space for it to cross safely. If not, the vehicle is asked to wait. This is how we can avoid deadlock before it happens. Another important part of deadlock is deadlock detection and deadlock recovery. Let's talk about the deadlock detection first. Deadlock detection allow deadlock to occur, then check for them periodically, use a resources allocation graph or wait for a graph. A cycle in the graph signals a deadlock. Deadlock recovery. Process termination about one or more deadlock processes. Resource permission. Take resources away and roll a process back. Goal: the break cycle with minimum cost to the system. In conclusion, a deadlock can cause a system to stop making progress, but by using preservation, avoidance, detection, and recovery technique, an operating system can manage them effectively. Thank you everyone for listening. I hope this Presentations help you understand the concept of deadlock. Thank you.